So we will discuss the construction of DC generator. So this diagram shows you the basic features, parts of the DC generator. So what are the important parts of the DC generator is the conductors, the armature, which is supporting the conductors. So there are slots in which we can place the conductors, and it is rigidly fixed with the help of wooden straps. And these are all the poles which is required to support, which is acting as a physical support for the field coils, in which will provide the supply, DC supply, in order to produce the flux. That is for DC excitation. So these field coils will produce the flux, and that flux will be distributed in a uniform manner over the armature with the help of the pole shoes. So this curved nature is nothing but the pole shoes. Usually the material used to prepare the poles are nothing but the silicon steel, because it is having very low reluctance and high permeability. Actually, what is meant by reluctance means it is nothing but the opposition effort for the flow of flux. So that is less in case of the silicon steel. And this is nothing but the commutator, and these are all the commutator segments, and this is nothing but the mica, which separates the commutator segments. So the commutator segments are physically intact, but they are electrically isolated with the help of the mica. And this is the shaft through which we can connect our generator to the prime mover. It can be coupled mechanically with the prime mover. And these are the brushes which will slide over the peripheral of the commutator, which collects the current from via the commutator. It will collect the current from the conductors and deliver it to the load. And this is the outer yoke or frame, which acting as a support for the pole shoes. The pole shoes are rigidly fixed to the yokes. And it may be called as stator also. So another picture for the construction of a DC generator, or in general a DC machine. So this is the outer yoke, as I already told, this is the outer yoke, and this is the armature conductors where slots will be there, and armature conductors will be placed in the slots. And armature conductor is also made up of silicon steel, and it is laminated. So another important point I want to mention here is both the armature core and the pole core. Core means it is a support for example, armature core means it is the support for the armature conductors, and field core means it is the support for the field coils. Pole core means it is the support for the field coils. Both the cores, pole core and armature core, are usually, it is not of solid structure, it is made up of thin laminations. After cutting it into number of thin laminations, between each laminations they will place an insulation, mainly epoxy resin, and then they will combine together as a single structure. This is to avoid or to reduce the eddy current loss. So here it shows the yoke, and this is the armature, as I told already, armature conductors are there, and this is the commutator, which is, the commutator segments are fixed to the conductors, armature conductors, and this is called a brush. Actually, if you see, the commutator is compared to your armature core, it is of small size, and thereby the conductors which are placed in the armature are connected to the commutator segments via a part called riser or lux. There is a part called riser or lux, which facilitates the connection between the armature conductors and the segments. And as I told, the brush are placed here. It is not fixed. It is not fixed to the commutator. Instead, it is just placed. It is in contact with the commutator's peripheral, but it is not fixed to it. It is fixed in a particular position, but not fixed to the commutator segments. So here, to make it easy, they have not shown the brush box just to handle the brush. There will be a brush box over here to handle the brush. It is not shown here. And this is the shaft which will be connected to the prime mover. This is your field, only the field poles without any field coils. In this diagram, they are showing the field poles which are also laminated. You can see that. And this is the feed to support the whole structure. So this is the cross section of the DC generator. We can see the clear picture of the DC generator. Once again, the poles, field poles, and the armature, which is having slots. This is called teeth of the armature, and this is the slot of the armature. And the armature conductors will be placed in the slots of the armature, and it is rigidly fixed because when it is rotated at a very high speed due to centrifugal force, it will come out. So to avoid that, they will fix rigidly that conductors in the slots with the help of a wooden wedge. And these are the air holes in order to for the cool air, atmospheric air to pass through it, and thereby it can take away the heatness produced when the generator is heavily loaded. And this is the key way of your armature, which is used to fix the armature laminations over the shaft. It should be locked in the shaft. For that, they are using a key way. And these are the slots, as I told already. Here they are showing the one lamination of the armature. So by combining more number of laminations of the armature, we can get a complete armature structure. So here separately they are showing the field pole, and there is a pole core and the field coils. So the field coils are usually form moved. It is form moved and it is just inserted in the field core, pole core. It will be rested on the pole shoes. This is the pole shoes. The purpose of the pole shoe, as I already mentioned, to distribute the flux uniformly around the peripheral of your armature. So these lines, what is these lines represents means it is not a solid structure. The pole core is not a solid structure. Instead, it is made up of number of laminations and combined together. And they are not electrically in contact. They are each and every individual laminations are isolated, electrically isolated, but physically they are in contact. So these two screws are called the countersunk screw, which is used to fix your pole, that is the field pole, over to your yoke. And this is the coil, as I already told, exciting coils. So we can see the field coil which is formed. Usually the field coil will be formed in this manner, and this field coil can be inserted over the pole core so as to rest in the pole shoes. And these field coils will be excited. Excited means it will be connected to the DC supply so as to produce a magnetic flux. And here in this picture we are seeing the armature core. So it is clear that once again these lines represents this armature core is not a solid structure. Instead, it is made up of number of thin laminations. So this arrangement of both the pole core and the armature core, which are not solid structure, instead they are made up of a combination of many number of thin laminations, which are electrically isolated. The reason is in order to increase the resistance of the whole structure. If you increase the resistance, the eddy current means current induced in these cores, not in the conductor, in these cores. It is called as eddy current. The loss produced by it is nothing but I square R. In order to reduce that eddy current loss, we are using this arrangement which will increase the resistance of the eddy current path. That is the idea here. So these, as we already saw, these are the slots in which we will place the conductors, and these are the teeth. Once again, these are the air holes for the air to flow, and thereby it can cool the whole armature. Whenever the generator is heavily loaded, enormous amount of heat will be produced, and that heat can be dissipated from the atmospheric air when it passes through this. And this is the keyway which is used to fix the total armature core with the shaft. It can be locked. So for our understanding, they are showing the one single lamination of an armature. It looks like this. The same thing. Whatever we discussed here, it is represented there. So here also, still the picture is somewhat clear, which explains you the armature lamination, how the single laminations will be there. And this shows the commutator segment and the rises. As we told already, the size of your commutator is somewhat less compared to the armature. But the conductors are placed in the armature only. Those conductors only should be connected to the commutator. So how to connect the conductor which are placed in a armature which is of greater size compared to the commutator means with the help of risers or lugs. There is another name for lugs called risers. Okay. And then we can see this arrangement is to once again fix your commutator to the shaft. It is called the end clamp. And this shows the brush box, the complete how the brush is folded. This black part is nothing but the brush. and this is called a brush box, and this is the spindle hole which will be fixed to the frame of the machine generator. So in this diagram we saw only the brushes. The brush box is not shown here. Actually the brush will be held in this position with the help of the brush box. So this is the brush box, and this is the spring, so as to make the brush to move to and fro, to avoid any wear and tear. In case if the commutator is not smooth, usually it won't be smooth. After prolonged usage it won't be smooth, it will become roughened. Because of poor commutation, it will become roughened. The surface won't be smooth. So during that time, if you fix this brush rigidly, means it will get teared or weared because of the rough surface of the commutator. To avoid that, to facilitate a to and fro motion of the brushes, we are using a spring arrangement. And there will be a wire, it is called as copper pick tile. The name why it got that copper pick tile means it looks like a copper pick tail of the pick. So this will be connected to the brush, and its another end will be connected to the terminal. So thereby it collects the current from the brush, and brush collects the current from the commutator. So this picture shows you the real picture of a DC machine, where you can see the commutator and the armature. These are the armature conductors, and these are the rises or lugs through which is connected to the commutator segments. And these are nothing but the insulation, mica insulation between the segments. In this picture, clearly we can see the segment and the mica insulation between each segments. And this shows the outer cover along with the pole, that is pole core, field coils, and the outer yoke of the machine. So this is another complete picture of a machine, DC machine, where we can see the ball bearings to reduce the friction of the mechanical friction. We are using the ball bearings. And this is the coil or conductors, armature core, insulation between the conductors. That's all. Thank you.